This talk and the JavaScript for WordPress Conference are brought to you by our sponsors at 10up and WP Buffs. 10up makes a better web with finely crafted websites and tools for content creators. Check out their junior and senior dev positions at 10up.com/careers. WP Buffs provides 24/7 fully managed support and white label agency services. Find out how they can help you focus on what you do best at wpbuffs.com/partnerships.
Hi, I'm Mike Crantea. I'm from Brașov, Romania. I've been with the X companies for 12 years now, since college. We've heard someone at 10up since college as well. We have those things at XWP as well. And today I will talk about progressive web apps. And let me share my screen. Okay, progressive web apps in WordPress. Progressive web apps might not sound too new, but in a lot of talks I had with many people, very few people know exactly what they refer to. So I will go through an introduction like, what does this refer to? A website which works well offline. Not a lot of people see many websites that do that. Looks and feels like a native app, has an icon on the home screen, and can request access and also use native device features. One important aspect is that all of these progressive web apps should be made in a way that they would still work in an old browser where support for the novel new features isn't there yet. I want to clear some of the common misconceptions the progressive web apps have. They are not the single page applications exclusive. They are not the core building block of PWAs, but you can turn a single page application into a PWA just like you can enhance a regular traditional multi-page application. You don't need to recode your existing website to add PWA features. And you don't need to implement all of them. Starting small is perfectly fine. So get your teeth right into it and bring in the features that interest you most or benefit your audience the most. Why is this important? To answer this question, we need to look at some studies. The first I'm showing here is the Comscore's Global Mobile Report from 2017 that shows up that 87% of a user's time on a mobile phone is spent in native apps, with only 30% on the mobile web. This is the US part of the full report, where other countries scored even 90% native, 90% plus native app usage. Native apps adoption. A minority of smartphone owners download more than one, making adoption difficult for new apps. This is part of Comscore's Mobile Lens study from May 2017, which shows the 3-month average for USA of apps downloaded in a month, where 51% of the users have not downloaded any new apps and a merely 30% one app. The 36% downloaded more than one app, but they still don't eat into the usage of the main 5 or 6 smartphone applications. Reach. PWAs have a higher reach than native apps while having access to the same capabilities, and this is a way to bridge the gap between the two worlds. Currently, the mobile web has a broader reach, but has a low engagement. PWA is the answer to increase engagement on an already broad audience. In Comscore's Mobile Matrix study from 2015, made on the top 1,000 mobile apps and compare them with the top 1,000 mobile web properties, we have 8 billion monthly unique visitors and only 3 billion monthly unique visitors in the native apps. While the engagement is of 200 minutes for the mobile native apps and merely 10 minutes for the mobile web. The engagement needs to ramp up on the mobile web in order to catch up with the native apps. 2 years ago, I was excited to hear that 1 billion people were running PWA-capable mobile browsers, which benefited from the PWA features. Then only Chrome did it. Now it's Chrome, Firefox, latest Safari, including iOS Safari, latest 2 Edge browsers, which all have support for the critical PWA features. That's 86% of the mobile web users and 83% of the web users in general. This is a huge count and improvement in only 2 years. We've only heard then, hey, we're going to add this in, and I didn't think that Microsoft and Apple will get this added this soon. So thank you, Apple. Thank you, Microsoft. We love it. Let's get them to use. A bonus feature is discoverability. PWAs are made in a way that they are discoverable, and Microsoft mentioned that they will start to actively crawl the web for quality PWAs and add them to the Windows Store for the users to discover. That will further increase the reach of the mobile websites which have ticked the PWA boxes. Let's get acquainted with the basics. In order for a website to be named a PWA, it needs to be reliable. It needs to load instantly and never show the offline page, even in uncertain network conditions. It needs to be fast, to respond quickly to user interactions, and with silky smooth animations and no janky scrolling. It needs to be engaging, to feel like a natural app on the device with an immersive user experience. When we should talk about performance, because the road starts with a fast website. The big gap that we're trying to fill is the fact that users need to see content quicker. 53% of users bounce from sites that take longer than 3 seconds to load. This takes into consideration the time to first meaningful paint metric, how long it takes until there is no longer a blank screen in the browser tab and the user can start reading content. Even though this is true, I've taken a look at the news websites, top news websites category in Alexa, which should contain a good roster of really fast websites due to their use case. And I found the same thing as everywhere. Mostly slow websites, a couple of fast ones. We can do better than that. The CNN and the New York Times don't paint anything on screen on a fast 3G until the 13 seconds mark, The Guardian at 4 seconds, Fox News at 4, and Huffington Post at 1. So we can do better than that. What should we do? As developers, we should build performance first. The performance enhancements should not be standard, should be the standard we start with, and then not the last-minute touch-ups. And we can start with optimizing the image delivery. Images are oftentimes the biggest weight in the network carries. Techniques to use, you should use a standard is to use the responsive images, use the SRC set and sizes, lazy load them, send the WebP format for the capable browsers, which represents 60% of the web browsers. And also know that Photon, the image optimization from Jetpack, does this out of the box. And you should also compress your images. This is a representative download screen from split by the content type, where we see that the images occupy 50% of the bandwidth, with the script second, HTML, and others coming in from behind. It's a common scenario where time is spent micro-optimizing relatively small files. So taking this example, if we start optimizing the CSS, which represents only 1% of the site weight, we won't get a big gain in how fast the page will load. While compressing a single image or loading responsively, the appropriate image size can chip away multiple levels of magnitude of page weight in comparison. If you're struggling with a huge bandwidth-eating website, images might be one of the culprit and require a bit of love and care. Give JavaScript the love it deserves. We need to care for JavaScript. As we've seen in my example, and it's usually the case most of the times, JavaScript is the second largest bandwidth eater. But beyond the fact that images load and take time to load, JavaScript also creates some issues. It blocks the CPU while parsing the JavaScript. The header scripts are block rendering, and this is the main culprit for subpar janky experiences. You can use the Chrome performance auditing to mimic real-life scenarios and audit the website such that you can see the jank. The jank is highlighted in the Chrome auditing tool that allows you to figure out, hey, these are the problems that I need to fix in order to not create a subpar experience for the users. Another issue is that the parse time of 1 megabyte of this graph shows the parse time of 1 megabyte of JavaScript. The median is at 2 seconds. With 1 megabyte of gzip JavaScript, which represents 4 megabytes of code, the average device takes more than 2 seconds just to finish parsing it, and it can go as high as 4 seconds on some. So when you keep adding more and more plugins and that depend on other libraries and so on, consider adding them just to the templates where they are needed. Because every time a new page loaded, even though you're not using that Lightbox library or that carousel on every single page, if it's something large, it will take time for the browser to parse the JavaScript and run it, regardless if it's used or not. Top-of-the-line computers and flagship mobile devices are common amongst developers, and they're at the very top here with almost instant parsing times of JavaScript, but they're not so common outside of the dev bubble in the real world. So we need to care for them and the long bars at the bottom of the graph over here. And because of the previous two slides, I recommend to use as standard the following techniques. The initial rendering of the web page should not depend on JavaScript. Always make sure to make use of the server-side rendering. Use the async tag when possible. Use async when you have a JavaScript asset that is not a dependency itself or does not have dependencies. Lazy load and defer JavaScript. Split the JavaScript codebase. Always late load analytics scripts, and offload any heavy JavaScript processing to a web worker, which has a 95% browser support, which runs on a separate thread. So just by defaulting to defer, you can take a website from taking, let's say, 6 seconds for the first paint, and keeping just the CSS render blocking, you might get it from 6 seconds to 2 seconds to render on a 3G connection. So it's worth thinking about that and making sure your inline scripts don't depend on something that needs to be made render blocking in order to run. This is currently a problem in WordPress, and I hope some 8 years old open ticket can hopefully move forward and make it easier for people to defer without manipulating strings to add that attribute. So we'll see how that goes. But keep on deferring, guys. And also, don't forget about CSS. Use critical CSS or inline it entirely, like AMP does it and makes it. You've seen how fast the experience is in AMP-R. Split the CSS code base on a template by template basis. It's probably difficult to do when you have a large code base behind, but when you start a new project, consider going that path out of the box. And clean the code base of obsolete features. In Lightbox, when you do an audit, you will see the percentages of a CSS file that's not used on a website. That might be an easy way for you to see, like, hey, this 7-8 features that haven't been used in 7 years from now can actually go away. I won't go into much more detail here, but keep in mind that CSS files are always render blocking. The bigger they are, the more delay you'll have in the time to first paint. Got a decently fast website. Now what? Once the performance best practices are in place, we can dive into taking this to the next level. Let's take the PWA checklist. The decent website checklist loads fast enough on 3G. Fast enough on 3G in Google's definition means aiming at web page test first view score of under 4,000 on mobile 3G and or a page speed insight score of over 85. They're not hard to get, but they are if you're having a lot of render blocking assets. Use HTTPS. It's standard nowadays to care for your visitors and their privacy. So just force it to HTTPS everywhere. Make sure that the website is responsive. We've done that for years now, so I won't beat around the bush. Make sure things work on any type of display possible. Shows content when JavaScript is not available. Even if you are having a website that has a React frontend or a Vue frontend, you can make use of server-side rendering, even with Node, or just do it in PHP if that's beyond if Node server-side rendering is beyond your reach. But make sure that visitors see something quickly before JavaScript kicks in, or if they have it disabled. And beyond the decent website checklist, I will move into the other parts that are inside of the baseline PWA. It needs to have a manifest which configures the custom splash screen and the icons when you place it on your home screen. It styles the address bar with the brand colors. You could do that in Chrome since many years now. It registers a service worker and responds with a 200 when offline. Now let's take the PWA specifics one by one. Add to home screen. Web app manifest. That's what we need in order to be able to prompt add to home screen in Chrome. Through the manifest.json file, we inform the browser about the web application and how it should behave when installed. This was inspired by Firefox manifest.webmanifest, and the key information contained within is pretty much the short name, the start URL, the colors of the application frame, the background color of the splash screen when the application is installed, and an array of icon sizes that the actual device chooses from when you're adding that website to your home screen. Microsoft uses browserconfig.xml for fetching the web application icons when they are added to the Windows start blocks, but they can also be present in the HTML instead. So that allows you to add to the home screen on a wide variety of devices. This is an example of how things work when you're adding an application to home screen. So you visit Pokédex a couple of times. The service worker is installed, and at a certain point, before install prompt event will be triggered and allows you, as the Pokédex developer, to present the add to the home screen banner to the visitors. This used to be automatic before. This is a new change that you have to listen to this event. You tap on the add to home screen button. You'll get a nice nifty little icon on your Android phone homepage. And when tapping the little icon, you'll see the splash screen with your custom defined background color and your application icon and the short name written underneath. Since this website had a manifest where it was defined to show up as standalone, it shows up without the browser Chrome. So it's just like a native application without you having to go to the Play Store or App Store to get it installed. It works offline with the service worker, not only when it's installed, but also in the browser. So when you're going in offline in airplane mode and you refresh a tab where you have the service worker installed and it has offline support, you will get the same capabilities like inside the installed application. It used to be new technologies, now they're now technologies. Let's dive into the current technologies that PWAs use. Technologies to get accustomed with. These have really solid support and should be used on a regular basis. Promises had been around for a while, and with the current support, they should be used as standard. You only need to polyfill them for IE 11. The Fetch API is here to replace the obsolete XHR HTTP request with a much nicer promise-based API. In the newer Chrome browsers, like the ones in the past couple of years, all requests translate into fetch events behind the scenes. Worth mentioning is IndexedDB, which has a whopping 94% support, and the service workers, which got their support increased from 60% a couple of years ago to 83% now. Polyfilling is not possible. IE and Edge 16 and all Safari don't support them, but we have pretty solid support on the latest two versions of Edge. The latest version of Desktop Safari, iOS Safari, all have support for service workers. So that's phenomenal. What are service workers? These are specialized web workers that run in a separate CPU thread. The main thing they do is that they proxy all of the network requests. They can interact with the cache API and retrieve assets from local cache or network, depending on the chosen caching strategy. It has hooks to enable starting the application or the site while offline. They support background sync and can send push notifications. The important thing about this notification is that they work even when the app or tab is not open. Let's chat about the cache API. With great power comes great responsibility. This adds the ability to put files into cache and keep the caches under version control. Storage is limited on some browsers. The unofficial recommendation is to aim at staying within 10 megabytes with your file. Developers need to clean up, delete old caches, and not cache non-essential files to avoid forcing the browser to clean up for them. So don't go caching your videos for offline, because you might not find them soon. Offline. With this offline hook, you can define custom offline pages and avoid showing the dinosaur. The cached HTML pages can be read in airplane mode. It plays really well with the cache API. And this allows implementing, for example, a save for offline functionality. And with the browsing capability of the cache API, you can eventually display links to the list of saved pages on the custom offline page. Like, hey, we don't have this page available for you while you're offline, but we saved this last couple of articles you've seen. You can browse them until your network comes back online, which is super handy, or when you're in an elevator. Background sync. It can update the cache in the background, even when the tab app is not open. An example usage is that it would instantly load with fresh data on the next interaction with the application. Let's take, for example, a news website where you have a gazillion breaking news. When you go back to the tab with that website or open the installed application, you would instantly see, without any loading time, the latest breaking news if you're syncing them with background sync. Push notifications. After you request the permission, it can bring the user back to the site even when the tab or site is not open. A couple of example scenarios. When a breaking news story got published, or when you're sending updates from sections the user is subscribed to. Let's say he's passionate about football and he's looking for the matches, and they can subscribe to a section, and when a new article gets published there, he finds the notification on his phone and he gets back to your website. It's sensible not to send more than one notification per day, or one risks the chance of creating an annoyance for some users. So play with it care, just like you'd like it to be. IndexedDB, that's an in-browser object store. It's non-relational. It supports cursors for iterations. It can be deleted by the browsers in case the host is low on space, based on the least recently used strategy. The IndexedDB API isn't the nicest to work with, but Localforge, which is a really tiny library, makes it makes a much easier way to work with, and it also has similar APIs around web SQL and local storage. It's worth mentioning that the regular workflow includes database migrations on the new service worker installation when a different database structure would be expected. You can use IndexedDB for storing AJAX requests, for example. Caching strategies. This is super important and a good thing to wrap your head around when discussing PWAs. The caching strategies need to be carefully picked. This is where the finesse plays a big part. You don't want to blow the engine, right? So there are 5 main caching strategies you'll find online: cache first, network fallback, network first, cache fallback, cache network race, cache only, and network only. And we'll take them one by one. Cache first network fallback is mainly used for the static websites, where you're caching the style sheets, the JavaScript assets, the layout imagery, the fonts. Network first cache fallback is what you should use for dynamic content when you want to always deliver the freshest content. For example, you would cache the HTML of the visited pages in order to display them when the user goes offline, and restrict it to a limited number of HTML files in order to avoid filling up the cache, for example. And when the network fails, the cache is delivered. When the network request fails, the cache is delivered. So there is a slight delay until the network request gets sound and it comes back. And IndexedDB is a good location to store and later retrieve dynamic data like AJAX JSON responses. So if your headlines are coming in JSON format, you want always to display the latest headlines. But in case the request for them fails, you're showing the last cached response, like with a 1 or 2 seconds delay or something like that. The cache network race. I found this to be super interesting. So for non-critical data, which can be updated on screen while the user reads the content, it's a 2-step process. It delivers the cached asset instantly, for example, a user icon first, while sending out the network request. As the network request succeeds, the asset is updated in the cache and updated and displayed to the user, swapped in front of his eyes. It should never be used though for the content that the user might read. Swapping it out while it was read creates a frustrating experience. And for content that's updated frequently, like game leaderboards, that's fine. The leaderboard is supposed to change every once in a while, so it's okay to swap that sort of data. The last network strategy, which is not much of caching, it's network only. For example, ads can fall into this category. Only checks the network, and if the network is unavailable, the request fails. Show's over. Cache only. For data cache during the service worker install event, you can depend on it being there. If you have your main style sheet, your main JavaScript file, your fonts, your layout imagery set up to be pre-cached as you install the service worker, they would never issue a new network request, for example, for checking whether a newer version is available on the server. For this caching strategy, you want to remove the old cache and bring in new assets as you release a new service worker version. And as that new service worker gets installed, to swap out the shell assets, and after its activation, you will be able to use the new set of assets. This thing gets really complicated. When you add all of those 5 caching strategies, you get a whooping large service worker file, which might be difficult to maintain and to debug if something goes amiss. So my suggestion is to use the Workbox library. Well, it's actually a collection of tools and libraries that are used in the context of service workers that helps with simplifying the caching, the routing, the background sync, analytics, and most importantly, debugging. It's easier to debug when you're using the Workbox dev tool locally, for example. Okay, debugging, it can indeed become quite time consuming if you're getting your first time into the service workers. And so it's good to have some actually well-tested code that you can iron out, like, hey, the bug cannot be here, it's somewhere else in my code. This toolbox is built by Google, and I added here a sample, really basic service worker. You import the workbox, you initialize it, and you use, hey, for pre-cache, I need these 3 assets to be loaded and these revisions. And they get added to the cache API for you using the proper caching strategy. All 5 caching strategies that I explained above are available in the workbox for ease of use. You can easily declare caching strategies for different paths using regular expressions, and this is a really nice to have, because you would like at some point to have different caching strategies depending on the type of the resource or the path to that resource. So in the left part, we see that we set up a route that matches all URL requests ending in HTML, and it handles those requests with a network-first strategy in order to be able to deliver them while offline. The second one sets up a cache with a maximum size of 2 entries. Once that's reached, the least recently used image gets deleted. Also, entries not used in more than 1 week get deleted. It only caches status OK responses. So you can see it's a pretty much, you're just configuring what you need for your application rather than going to the nitty-gritty of adding the proper cache API table and storing things inside it. Anything noteworthy happening right now? Yes. Just a couple of weeks ago, I've heard about the Frontity effort. They are working on single page application PWAs, and they have created an extensible framework to build headless WordPress themes using React. It's also using Node to do the server-side render, which was super nice, as there was no white screen waiting, and then refresh to get the React interface going. You can check them out at github.com/frontity/frontity. And the PWA from WordCamp Europe in Belgrade was built by them. That's how I heard about them. And there's a good chance that you've seen this at work on your phone already. I'd keep an eye out over their developments, as they're going in a nice direction. Bringing PWA to the WordPress masses. There's a feature plugin we're working on to bring PWA to WordPress core. The feature plugin is created to facilitate plugins to be able to work together in their respective PWA functionalities. Doing PWA in WordPress today is possible, but 2 plugins can both register service worker functionality. So before this, you have going with one or the other. But with this, we want to create an API that allows one plugin to enable a certain PWA feature. So let's say this plugin handles really well notifications. This other plugin handles really well working with the native camera on your device. And we hope to bring this gap together and make it possible that they would work on the same time. Along with service workers, being able to have a single source for the web app manifest, which plugins can amend and extend with filters, is also one of the areas we are focusing on. And then lastly, having better HTTPS support at the foundation. The goal for this is to provide an easy way for website owners to tick the baseline PWA checklist items, while developers to have all of the needed APIs to take you to the next level. We're mostly building on top of prior art, trying to take both established patterns for PWAs in WordPress and combine those with new APIs to make it standardized and interoperable between themes and plugins. If you want to contribute or check it out, go to github.com/xwp/pwa-wp. Thank you very much.
Thanks for watching this talk from the JavaScript for WordPress conference. If you're interested in more talks like this, head over to javascriptforwp.com/conference to see an archive of all talks, as well as information about upcoming events.